Welcome class 8th. Class 8th, we were doing chapter 5, light energy, and I have already introduced you the topic spherical mirrors. Fine. And as you know that spherical mirrors are basically of two types. Yes. Which are they? Concave mirror and convex mirror. Yes. Concave mirror and convex mirror both are known as, together they are known as spherical mirror. Okay, so you can say that spherical mirror is of two types, concave mirror and convex mirror. Secondly, both the mirrors are curved mirrors. You can see they are curved in shape, so they are curved mirror. And what is the difference between concave mirror and convex mirror? In concave mirror, concave, just relate it with the name. Concave, just like a cave. Okay, so here also, just like a cave, the inside, or you can say the inward side of this mirror is the reflecting surface, whereas the outer side or the bulging side is polished. Whereas in convex mirror, the inward side is polished, or you can say it is coated, whereas the bulging side, bahar wali side, the bulging side act as the reflecting surface. Fine children? Okay. Now today we are going to study terms related to spherical mirror. Means what all are the parts which are involved in spherical mirror. Now the very first is your pole. Okay children. So what is pole? The geometrical center of the spherical mirror is called the pole of the mirror. It is denoted by P. Children, let me tell you, these all the parts which are given here, they are very important. It may come in either in the form of fill in the blanks or in the form of define. Fine. So don't think that they are just to be readable part. It is not only readable part. Here you have to pay attention also. Okay. So pole is the geometrical center of the spherical mirror, and it is denoted by the symbol P. Now you can see children, here it is the mirror, and you know that this is the mirror because it is the part of the hollow sphere. You know that mirror or curved mirrors are obtained from a hollow sphere. So if this is the mirror, M dash is the mirror which has been the part of this hollow sphere. So the geometrical center of this mirror, you can see the center of this mirror is this point P. And this point, the center of this mirror, the geometrical center of the spherical mirror, you know, this is a concave mirror and it is a spherical mirror. Yes. So the geometrical center of this spherical mirror is known as pole. Fine. And you can see it is denoted by capital P. Now, I told you that suppose if I say suppose if I say this is your concave mirror. You know that in concave mirror, the outer, or you can say the bulging side is polished. Yes. And inner side is reflecting. Now, this concave mirror has been obtained from a hollow sphere. Yes, if you imagine if it would have been a hollow sphere, so it would be like this. Yes. So iska matlab this mirror, the name is M, this point M dash. M dash is the part of the hollow sphere or not? Yes. And this, what is pole? The center of the spherical mirror. If M dash is the spherical mirror, which kind of a spherical mirror? Concave mirror. तो इसका जो center होगा, this, suppose this is the center. So the geometrical center of the spherical mirror, which is denoted by capital P, is the pole of the mirror. So this is your concave mirror children. Yes. So iska geometrical center, suppose this is the geometrical center here. Okay, the center of this mirror. So this is the pole of the mirror. And same way in the, this was the case of the concave mirror. If I talk about convex mirror, you know that in convex mirror, what happens? In convex mirror, the inner side is polished. Yes. And outer side is reflecting. Same way here, it must be a part of the hollow sphere. Yes. Yes. Suppose this part we have taken the geometrical center of this mirror. Mirror we have taken from here till here. So the center is here, P. So this is the pole of the convex mirror. I hope children I am clear to you. Yes. Now you can see same thing here in the diagram also in your book. Suppose this is the case of the concave mirror. This is the case of convex mirror. Okay. So in concave mirror, the geometrical center of this mirror, dash is this P point. The midpoint is the P is the pole. And same way you can see here the inner side is polished. So here the center is this, which is in the case of convex mirror. I hope children it is clear to you. The geometrical center of the mirror, either it is concave mirror or convex mirror, uska jo geometrical center hoga of that spherical mirror, that is called the pole of the mirror, and it is denoted by capital P. Now next is your center of curvature. Children, pay attention line by line and word by word. Okay. The geometrical center of the hollow sphere. Just pay attention here. The geometrical center of the hollow sphere of which spherical mirror is a part is called its center of curvature. It is denoted by capital C. Now pole, or you can say capital P, was the part of the this spherical mirror, and this C, that is your center of curvature, it is the center of the, or you can say it is the geometrical center of the hollow sphere. Okay, geometrical center of the hollow sphere, which is denoted by capital C, is your center of curvature. Fine. Again I am showing you here on this paper. Suppose this was the mirror and it has been the part of this hollow sphere. So इस पूरे hollow sphere का जो center होगा, that will be your center of curvature, and it is denoted by capital C. Same way, the center of this whole hollow sphere, that is here, it is your center of curvature, and it is denoted by capital C. I hope children it is clear to you. Now next is your principal axis. Okay. The straight line passing through the pole and center of curvature of the spherical mirror is called the principal axis, and it is denoted by PX. Now you can see PX is the straight line. Yes, and it is passing through the pole of the mirror P and center of the curvature of this hollow sphere. So this line PX, which passes through the pole of the mirror as well as the center of the curvature of this hollow sphere, is known as your principal axis. Same way here, a line PX which passes through pole of the mirror and center of the curvature, this is the line which is known as principal axis. So the straight line which passes through pole of the mirror and center of the curvature is known as your principal axis, and it is denoted by capital P because P is the pole and the end point is your X, so it is named as PX. So same way, if I tell you here, so a line or a straight line which passes through center of curvature and pole of this mirror, suppose if I name it here X, so this PX is your principal axis. Same way, a line which passes through pole of the mirror and center of the curvature, this line is your PX line is your principal axis. I hope children this was the case of the concave mirror and this is the case of the convex mirror. I hope children it is clear to you. Yes. Now radius of curvature. Next is your radius of curvature. The radius of the hollow sphere. Just note this word. The radius of the hollow sphere of which spherical mirror is the part is called the radius of curvature of the mirror. It is denoted by small r. Okay, the radius, as you have studied the circles, in circles also the center is there. Okay, and radius is there. Same way in hollow sphere also, if the center of the hollow sphere is this C is your center of curvature, then there must be a radius also. Okay, so what is this radius of curvature? The radius of the hollow sphere of which the spherical mirror is the part, means the radius of this hollow sphere of which this spherical mirror is a part. So this radius, okay, this radius or you can say this distance. Fine. This distance from pole till center of curvature is your radius of curvature. Okay, what is radius of curvature? The radius of this hollow sphere. But if this C is your center of curvature, so radius of curvature क्या हो जाएगा? The half of the C whole line, px का half. Okay, so PC, this is the radius of curvature, whereas CX, it is also the radius of curvature. So it is the radius of curvature is the radius of this hollow sphere. इस hollow sphere के radius को radius of curvature कहते हैं, and or you can say it is the distance from pole till center of curvature, pole of the mirror to the center of curvature. I hope children I am clear to you. Yes. And if I show you here on this paper, so this length from pole till center of curvature, this is your radius of curvature. Okay, this length from pole till here is your radius of curvature. I hope children it is clear to you. Yes. Now, next is your principal focus or focal point. The point on the principal axis. Okay, principal focus or focal point. Now be careful children, the line which I am reading, the point on the principal axis where all rays of light parallel to the principal axis meet or appear to meet after reflection is called principal focus of a spherical mirror, and it is denoted by capital F. Okay, now point on the principal axis. Just look here on this diagram where I am pointing out. You can see this is the mirror. This mirror has been taken from a hollow sphere. Yes. This is the P is the geometrical center of the spherical mirror. Spherical mirror. P is the geometrical center of this spherical mirror. Which kind of a spherical mirror? Concave mirror. And this PX is the line which passes through center of curvature and pole of the mirror. So, what is this your principal focus or focal point? The point which lie on the principal axis, and at this point what happens? The rays of light which are parallel to principal axis, when they reflect from this mirror, after reflection all these rays they meet at the point F. Either they meet at the point F or they appear to meet at the point F. Okay, now just pay attention on this line. In a concave mirror, all rays of light. Now you can see it is a concave mirror. In a concave mirror, all rays of light parallel to the principal axis. Now you can see these are the rays of light which are going or which are going to strike on this mirror, and these lines are parallel to the principal axis. Yes. So all rays of light parallel to the principal axis converge. Converge means they meet at one point. They converge after reflection and meet at the principal focus. Okay. Now you can see in case of concave mirror, the lines or the rays which are parallel to principal axis, you can see these are the rays which are going towards the mirror. You can check by these arrow. So after reflection from the mirror, they meet or you can say they converge at a single point, that is known as your principal focus or focal point. And you can see that this point lies between center of curvature of this hollow sphere and the geometrical center of this spherical mirror. Center of curvature or pole के बीच में this principal focal or you can say focal point lies. So in case of concave mirror, all the rays of light जो कि आ रही हैं दूर से and which are parallel to this principal axis, after reflection they meet at the point that is known as your principal focus or focal point. And due to this property of the concave mirror, this concave mirror is also known as converging mirror, because concave mirror has a property to converge all the rays at a single point. But whereas if I talk about convex mirror, so in children, convex mirror, you know that the outer side or you can say the bulging side is the reflecting side. So again, you know, you can see this is P is the geometrical center, PC, this is your principal focus. So the rays will come and they will strike on this bulging side. Yes, you can see in this diagram. when the rays are coming parallel to the principal axis and they are reflecting on the outer side, in case of convex mirror, you can see that convex mirror has a property to diverge the rays. Just remember this thing, okay? Concave mirror has the property to converge and convex mirror has the property to diverge the rays. तो जैसे ही rays parallel जा रही हैं, after striking they are diverging. You can see they are diverging in different direction. And when you are going to extend this line backward, so it seems, or you can say it appears to seem that the rays are coming from principal focus. ओके ये क्या होंगी, जैसे रेज इस पे स्ट्राइक करेंगी ये डाइवर्ज हो जाएंगी. एंड व्हेन वी आर गोइंग टू एक्सटेंड दीज लाइंस बैकवर्ड, तो हमें ऐसा लगेगा कि द रेज आर कमिंग फ्रॉम प्रिंसिपल फोकस ओनली. इन विच केस, इन केस ऑफ कॉन्वेक्स मिरर. सो यू कैन सी हियर दैट इन कॉन्वेक्स मिरर all rays of light parallel to the principal axis diverge after reflection. As I told you, it is the property of the convex mirror to diverge the rays after reflection, and that appears to come from principal focus. And due to this property, convex mirrors are also known as diverging mirrors because they have the property to diverge the rays in different directions. I hope children it is clear to you. Concave mirror has the property to converge the rays, okay, and they get converge at a fixed point, that is your principal focus. Same way convex mirror has the property to diverge the rays. और जब ये rays diverge हो जाती है and when we extend these rays backward, it seems to appear, हमें ऐसा लगता है कि they are coming from focus only, principal focus only. I hope children it is clear to you. Fine. If I show you on this paper, suppose this is your which mirror? If the outer side is polished, this is your concave mirror. Suppose this is the geometrical center pole of this mirror, and let us name M dash as the name of the mirror, and P is the geometrical center of this mirror. Suppose I am not using scale, children, I am drawing freehand, so just don't mind that if the line is not straight. So suppose this PX is the principal axis, okay, and if I assume that if I have taken this mirror from the hollow sphere, suppose this is the center, geometrical center C, yes, center of the curvature of this whole hollow sphere. Now it is said that the focal, or you can say the principal focus, it lie between pole of the mirror and center of the curvature. Suppose here it lies between at equal distance from the center of curvature and pole of the mirror. And in case of concave mirror, what happens? If the rays are coming parallel to principal axis, you can see rays are coming parallel to principal axis. So after reflection, they will pass, or you can say they will converge at a which point? After reflection, they will converge at a single point which is known as your principal focus or focal point. Now this was the case of the concave mirror. Now what happens in convex mirror, children? Suppose this is your convex mirror. In convex mirror, the inside portion is polished. Yes, and it must be a part of the hollow sphere. Fine. Suppose this is the geometrical center. This is the pole of the mirror P. PX is the line which is the principal axis. Now the rays will come where? Rays will come from here on the outer side, and let us say here the principal focus will be here. Always remember that principal focus, it lies between pole of the mirror and center of the curvature. Now you know that in case of convex mirror, the outer side is, or you can say जो बाहर वाली side होती है, that is your reflecting surface. So rays will come like this, parallel to the principal axis, and you know they diverge. This is the property. Rays आ रही हैं, diverge हो रही हैं. They are getting diverged. So if I'm going to extend, children, I'm not using scale, so it is not coming straight. If I'm going to extend this line backward, So it will appear that these lines are coming from principal focus. Okay, you can see I have not used scale, so I will show you from here. See, this is the case of convex mirror. So रेज आ रही हैं और डाइवर्ज हो रही है, रेज आ रही हैं और डाइवर्ज हो रही हैं. और अगर हम ये पीछे की ओर एक्सटेंड करेंगे तो वी विल फील दैट द रेज आर एक्चुअली कमिंग फ्रॉम प्रिंसिपल फोकस ओनली. In which case? In case of convex mirror. So I hope children it is clear to you. Fine. Now the next part will be coming very soon, in which I am going to explain you from focal length.